Hey guys. So today we are in chapter 5. I think we start with 5.1.3 and we are talking about graphing. So let's give that a look. Hold on. Okay, so the first section, 5.1.3, is about interpreting graphs. And so these are just kind of sketches of graphs. Like if I have this and I have the time it takes you to, time versus distance. And we do, like you're running. So sometimes you run real fast, and then you might take a break, and then you might run real slow, and then you might sprint to the end. Does that make sense? So it's just like a graph without, it doesn't even have to have numbers, just kind of an explanation. So there's only two questions I think on the homework, but it's just the idea that, like here I said, like you started running. This would mean I was not running at all because time is happening, but no distance is increasing. So time is constant, but no distance is changing. So this would be like stopping. And then you could run slow, and then if I ran fast, it would be a lot of distance over a little time. So that's 5.1.3, super easy, just explaining interpreting graphs. So the next one is 5.1.4, and this one is talking about input and output and tables. So we talked a little bit about this last week, but if I give you y equals x plus 4, okay, so for every value of x, because this has to do with ordered pairs, for every value of x, there's a corresponding value of y. So if x is 1, then that would be 1 plus 4, so y would be 5. Okay, if x is 2, that would be 2 plus 4, so y is 6. Okay, you with me? So I'm just putting a number in for x, doing whatever I'm supposed to do with it, and then I get a y. Now, eventually that would mean that I would have an ordered pair 1, 5, or 2, 6. Remember, ordered pairs are an x and a y. And I could graph those points, and I could connect them, and I can make a line. So this is algebra. This is what you're headed into for algebra, is this basic idea, functions, where I have an input, I do something to it, I have an output, I have an ordered pair. So like I could say x is 10. Well, 10 plus 4 is 14, so 10, 14. I could say x is negative 2. So negative 2 plus 4 is 2, so an ordered pair would be negative 2, 2. This is 5.1.4, and you deal with the same thing in 5.1.5, I think, or in 5.2 point something, where you actually go to graph it. Okay, so like I said, I could graph these ordered pairs: over 1, up 5, over 2, up 6, over 10, up 14. So you would make a line. Okay, so this is most of the rest of this work. So let's do another one. Okay, let's do y equals 3x minus 2. Okay, so I have x, I have the rule, which is just 3x minus 2, I have y, and then I can go ahead and put ordered pair. Okay, so if x is, and x can be any number, right? So it usually they might tell you. So let's do 0, 2, negative 2, 0, and 2. Okay, so 3 times negative 2 minus 2. So 3 times negative 2 is negative 6, minus 2 is negative 8. So the ordered pair would be negative 2, negative 8. Okay, 0. 3 times 0 minus 2. Well, 3 times 0 is 0, minus 2 is negative 2. So the ordered pair would be 0, negative 2. 3 times 2 is 6, minus 2 is 4. So 2, 4 is the ordered pair. And then I could graph those. Negative 2, negative 8, 0, negative 2, 2, 4. And that's just a quick little sketch. I would need to connect those. So a graph paper would be helpful. But hopefully that gives you an idea of how these kind of problems work. So there's several of them in like 5.1.3 all the way through 5.2.1, I think, is all dealing with kind of this same thing. So one of the sections is about describing the sequence, which means like finding the pattern, and that's pretty easy. Like, are you multiplying or are you adding to get to the next number? So like if I had a set of x, y values, so let's see. Okay, so what am I doing to get from x to y? So this is plus 4, this is plus 6, so that's not going to work, because see, it'd have to be the same every time. This, so let's try, so we tried addition or subtraction, you know, try adding. Let's try multiplying. 2 times what is 6? Times 3. 3 times what is 9? Times 3. Oh, do you see how these are all times 3? So our rule would be x times 3. Y equals 3x, because I'm taking all the x values and I'm multiplying them times 3. So see how you can come up with the rule if you have the table? So let me do another one. Okay, what am I doing every time to get from x to y? So it's not from one y to the next. It's what am I doing to get from x to y? So it's multiplying by 2, but does that work for anything else? No. It's adding by 4. See how that works? So the rule would be y equals x plus 4, because I'm taking every one and adding to it. Okay, so these really aren't super complicated. What I want y'all to do, because this was just, I talked really fast and kind of quick, so what I want you to do is the subchapter. I think it's the 5, that's not how you spell subchapter. Subchapter. I think it's 5.1 subchapter. So if Ms. Clark will put it on the screen and y'all can just go through and do you know, half the problems, y'all can have the subchapter worksheet done. So do the subchapter 5.1 and then we'll just talk to you later. Bye guys.